Space, the final frontier. For millennia, humanity has gazed up at the stars, filled with wonder and curiosity about what lies beyond our planet. But how do we traverse this vast, empty expanse? Today, we'll delve into the science of spacecraft propulsion, uncovering the principles that enable us to journey beyond Earth's atmosphere and into the depths of the cosmos. At the heart of spacecraft propulsion lies a fundamental principle of physics known as Newton's third law of motion. For every action, there is an equal and opposite reaction. This law underpins the mechanics of how rockets and spacecraft generate thrust. When a rocket expels gas out of its engines, the force of that gas moving in one direction pushes the rocket in the opposite direction. This principle is the cornerstone of all rocket propulsion systems, transforming chemical energy into kinetic energy. Most spacecraft utilize chemical propulsion, which relies on exothermic chemical reactions to produce thrust. In a typical rocket engine, two components, fuel and oxidizer, are combined and ignited, leading to a rapid expansion of gases. These gases are expelled through a nozzle, generating thrust according to Newton's third law. This method has powered many of our greatest achievements in space travel, from the historic Apollo missions to the advanced Mars rovers. Take the Saturn V rocket, which launched astronauts to the moon during the Apollo missions. This engineering marvel generated an astonishing 7.5 million pounds of thrust from its 5 powerful F-1 engines, propelling the spacecraft beyond the confines of Earth's gravity. The Saturn V remains the most powerful rocket ever built, a true testament to human ingenuity and determination. The launch of Apollo 11 in 1969 not only marked a monumental milestone in space exploration, but also demonstrated the effectiveness of chemical propulsion in overcoming the challenges of leaving our planet. The Saturn V consisted of multiple stages, each designed to perform specific functions during ascent. As each stage expended its fuel, it would be jettisoned, reducing the spacecraft's mass and allowing the next stage to take over. This multi-stage approach is a common feature in rocket design, maximizing efficiency and enabling spacecraft to reach the high velocities needed to escape Earth's gravitational pull. While chemical propulsion has been immensely successful, it's not the only method available. As we set our sights on longer missions and deeper space exploration, scientists and engineers are developing alternative propulsion technologies. One promising method is electric propulsion, which includes ion thrusters and Hall effect thrusters. Ion thrusters operate by using electricity to accelerate ions, charged particles, to create thrust. Unlike traditional rockets that burn fuel, ion engines expel ions at incredibly high velocities, allowing spacecraft to achieve efficient and sustained thrust. The Dawn spacecraft, which explored the asteroid belt and the dwarf planet series, employed ion propulsion to travel vast distances with minimal fuel consumption, showcasing the potential for deep space exploration. Electric propulsion systems like ion thrusters offer significant advantages in terms of fuel efficiency. Although they produce less thrust than conventional rockets, they can operate for extended periods, sometimes for months or even years, making them ideal for long-duration missions where fuel conservation is paramount. This efficiency allows spacecraft to carry less fuel, freeing up space for instruments and supplies essential for exploration. Ion thrusters can achieve speeds up to 90,000 kilometers per hour, significantly enhancing the range and capabilities of spacecraft. Another innovative approach to spacecraft propulsion is the solar sail. This method harnesses the power of sunlight to propel a spacecraft. By utilizing large, reflective sails that catch photons from the sun, solar sails can gradually accelerate without relying on traditional fuel sources. The Planetary Society's Light Sail mission demonstrated this technology, showing how we can leverage the sun's energy for exploration. Imagine a sailboat gliding across the water, propelled by the wind. That's how solar sails function, but in the vacuum of space. This method holds tremendous promise for future missions, allowing us to explore distant regions of the solar system and beyond without carrying large amounts of fuel. As we develop larger and more efficient solar sails, we could potentially reach the outer planets and even interstellar space. Some concepts propose using solar sails equipped with lasers that could beam energy to propel spacecraft even faster. As we look even further into the future, nuclear propulsion offers another exciting avenue for space travel. Two primary concepts are nuclear thermal propulsion and nuclear pulse propulsion. Nuclear thermal propulsion utilizes a nuclear reactor to heat a propellant, such as hydrogen, which is then expelled to create thrust. This method has the potential to provide high thrust and efficiency, making it suitable for crewed missions to Mars and beyond. Nuclear pulse propulsion, famously depicted in science fiction, works like Project Orion, envisions using controlled nuclear explosions to propel a spacecraft forward. While this method remains theoretical, it highlights the innovative thinking driving our quest for new propulsion technologies. The potential for nuclear propulsion systems to drastically reduce travel time to distant destinations could transform human exploration of the solar system. As we set our sights on ambitious goals, such as returning humans to the moon, establishing a presence on Mars, and even exploring the outer planets, the need for advanced propulsion technologies becomes increasingly urgent. Each method of propulsion brings its own set of advantages and challenges, and ongoing research will determine which technologies will be employed in future missions. The Artemis program, aiming to return humans to the moon by 2024, will rely heavily on powerful chemical rockets, specifically the Space Launch System, or SLS. Meanwhile, the upcoming Mars missions may employ a mix of propulsion technologies, including electric and nuclear systems, to optimize efficiency and safety for crewed journeys. The goal is not only to reach Mars, but to establish a sustainable human presence there, paving the way for future exploration of the outer planets. International collaboration is also reshaping the future of space travel. Countries around the world are pooling their resources and expertise to develop advanced propulsion technologies, as well as shared missions. The European Space Agency, NASA, and private companies like SpaceX are all contributing to a new era of exploration. Together, they are pushing the boundaries of what's possible, making ambitious missions more attainable. Companies like SpaceX are revolutionizing access to space with their reusable rocket technology. By reusing rocket components, they significantly reduce costs and increase the frequency of launches, making space more accessible than ever before. Their Starship spacecraft, designed for missions to the Moon, Mars, and beyond, incorporates advanced technologies that will play a crucial role in the future of space travel. So, the next time you gaze at the stars, remember the incredible science and engineering that propels us into space. The journey from our planet to the cosmos is a testament to human ingenuity, resilience, and our insatiable desire to explore the unknown. With each new technological advancement, we unlock new possibilities for discovery, pushing the frontiers of our understanding and expanding our reach into the universe. Thank you for joining us on this exploration of spacecraft propulsion. We hope you leave inspired by the wonders of space travel and the endless possibilities that lie ahead in our quest to explore the universe. Every mission brings us closer to understanding our place in the cosmos and ignites our collective imagination for what lies beyond. As we continue to innovate and expand our horizons, who knows what marvels await us in the great expanse of space?